Hi everybody, we're back with science today, so I want to share with you some fun science experiments. So the first one we're going to do, you need a glass of water, right, like that, and then you need a pencil, like that. Now you can see that this pencil's straight, right? And so when we look at something, we see something because, now let's make a hypothesis. What allows us to see? What is it that we need to be able to see something? We need our eyes because we don't see through our nose, right? We don't see through our ears, right? We need our eyes, and we need something to go in our eyes so it will make it possible to see what is there. Can you guess? What do you think it is? It's light. We need light. So teacher Chaia has this lovely light up above me, and I would be outside, but I'm not today because it's raining. So we're going to need some we're going to need some artificial light. That's not real light. That comes from a bulb, or it's not outdoor light. Can you tell me what is outdoor light? What is it that lights the sky outside? What do you think? Is it the sun? Yeah. And the moon bounces off the light of the sun. So at night, the moon is our night light. And even stars have a little bit of light. I don't think they shine on us, but they're definitely bright. So those are sources for light, and they help people navigate. If they're on a ship, the stars will help them see at night. But we don't have that inside. We have candles, and we have light bulbs. So that's what we're going to use today. It's a light bulb to see. But when we see something, we have to see it through the air. But what happens when you see something, but you see it in the water? So I want you to put your science hats on again and tell me, what do you think is different when you see something when it's in the air and when you see it when you put it in water? And here's my answer. We're going to find out. Here's my straight pencil. But when I put the straight pencil in the water, you will see that when you look at home more easily, but you will see that the light in the water, oh, there you go, changes. And the water is wiggling the light. And guess what? Do you see? It looks like it's in two pieces. Isn't that cool? That's really cool. There you go. There's your broken pencil. But it's not really broken. So why does it look broken? Because the light bends when it's in the water. Like a rainbow. When you see a rainbow, it's the shape of an arc, right? It's bent. The light is coming from one thing, but it takes its own shape when it's reflected with water and light and air mixed together. So when the sun hits water, it makes a rainbow if it's raining outside, right? So the whole sky is bent, has a bent, beautiful colored rainbow, right? We have a bent, beautiful colored pencil here. So this is really cool. It's magic and it's science. So that's my first experiment with you guys. And you can try it at home with different things. But if you have a pencil or something like that, you can definitely try it just like what I did. Okay. The second experiment is super fun. But you need a balloon, or you need a balloon, and you need to rub it on something that will take the electrons and move them from what it has inside. Like my sweater has all these bouncy electrons, and they are bouncing around all the time. We don't see them, but they're bouncing. But when we rub a balloon on our sweater, guess what happens? I'm going to tell you. The balloon is where the electrons jump to the balloon. It's a negative charge on a positive charge, so they are attracted to each other. And the electrons go on the balloon, and they're bouncing around so fast that they can bend water too. Now, I'm going to pour some water in the sink, and I'm going to flip this phone around so you can see it. Let's see how it works. Let's see. Uh-oh, I'm not sure how to do it. Let's see. Well, we're going to do it this way. We're going to turn my phone. So, I'm going to pour the water and move it near the balloon, or the balloon near the water, and you can see what happens to the water. You ready? All right. Here's the water, and here's the balloon. I'm going to see it's wiggling when I do that. It wiggles when I do that. Let me show you again. I'm going to rub it fast, and I'm going to make the water a little less heavy coming down. Water is very cool. It gets heavier if it's flowing longer, but let's just see. Really little bit of water, just a little bit of water. Okay, can you see the little bit of water? Okay, so it's going to move better. Here I'm rubbing my balloon. Hang on, we're going to rub, 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 rub. And if you don't have a sweater, you can rub a shirt. You can rub your hair. And then let's see if you can see it move. Do you see? Is that cool? Okay, let's see if you can see it from the back. Let's see. If I move it. Oh, it goes away fast. Gotta rub, rub, rub. Here I'm rubbing. Here I'm rubbing. Okay, balloon. Are you ready? Here goes. And it's wiggling the water. And I think this balloon needs more air. So parents, make sure you put a lot of air in the balloon. This has been air's been inside for a little while. And it wiggle, wiggle, wiggles. And they are both, they're different actually. One is negative and one is positive. So they are attracting to each other, attracted. They love each other. So the water is going to go nearer to my balloon. All right, one more try so we can really show you. If it doesn't work as much as I did the first time, we'll get another balloon going. So here, let's try it. Ready? It's wiggly, it's wiggly. I can see it. I don't know if you can see it. Let's see. And it bends it really bendy when it's really full. All right, that's the second experiment. Now, the third experiment is not really an experiment, actually. It is how to make a little guitar so you can play with me. Now, when we're making sound, we need something more than just our sound. We need it to be carried on something. So we're going to carry it on a rubber band. A rubber band is stretchy, right? So when you stretch a rubber band, what happens? Put your science hat on. Does it get tighter or looser? When I stretch it, it gets tighter. And when it's tighter, guess what happens? The tension, the part that makes it straight, makes the waves when you pluck it, it makes it go faster. So the air goes faster if it's tighter. And if the air goes faster, it's like a wave in the ocean. It goes up and down, or kind of undulating like that. And it goes faster if you make it tighter. And if it goes faster, the sound gets something higher or lower. What do you think? Who says higher? And who says lower? Can you hear the difference? I'll do it real low. Hang on. Real loose. Well, I'll show you on the box because you can't really hear it so well, right? But when I stretch it over the box, the sound gets to bounce. You like to bounce, right? Sound likes to bounce too, so it's going to bounce from the back of the box to your ears. So this time you don't need your eyes as much, you need your ears. Ready? So I'm going to put it down because I can't hold both at the same time, but I'm going to see if you guys can hear it. Ready? Here we go. Now they're going to be different. Here's the blue one. It's a little thinner. See? Can you hear it? That sounds pretty cool. Much louder than it's on my fingers, when it's on my fingers. All right, now, this fat one, thicker one, is going to be what? Lower or higher? What do you think? It's thicker. That's going to make a difference. Listen carefully. Yeah, what do you think? Higher or lower? Here's the first one. And here's the second one. Sounds so cool, doesn't it? I think the second one's not as high. I think it's lower. It's like a little doggy. Woof, 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 woof. And here's a bird. Tweet, 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 tweet. Or meow, meow. Woof, woof. Meow, meow. Woof, woof. Now I have another one that's very thin. So it stretches better, so the thing is, it will be looser. So it won't have as much of a bounce because the sound waves aren't really bouncing as much when it's looser. They're slower. They're not bouncing as much. So listen to this. Not bad though, huh? I'm playing it very lightly. If I played it hard, it wouldn't sound as good. Listen. Snappier sound. This is better. Can you hear it? Bum, 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 bum. Can you sing with me? Bum, 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 bum. Can you sing this one? Bum, 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 bum. And here's another one. Bum, bum. What's higher? Bum, bum, bum. It's the same as this one, but a little bit skinnier. And this is a little bit tighter, so it's higher. Bum, 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 bum. And you can put 20 of these on a box. It's fine. You can make as big an instrument as you want, or as many strings on it as you want. Now, if you really want to have fun, you can add this toilet paper tube. No, it's not a toilet paper tube. It's a paper towel tube. It's a long one, and that makes it like a real guitar looking. Do you see? And you can stick it in. You have to make a hole. You need some help. But then at home you could do that. And then you can make it look like a real guitar. Otherwise, you just have the box. So it's just like your body. This box is like the back. And then the paper towel tube would be like the neck. And it doesn't have a head because we don't have a head piece for this. But it could. It could have the keys and the little top part like a guitar has. And here's the back. And here's the front. And here's like the mouth. It comes out. That's where the sound comes out. So pretend your mouth is open, and then let's pretend your mouth is closed. Ready? Okay, so close your mouth and don't let the sound come out, but still try to make it. Ready? Not bad. It kind of comes out your nose, and it goes through your muscles and your sinuses and your face. Those are the part where you can breathe. And then, or can't breathe if they're stuffy. And then we're going to open our mouth. Ready? And let's see how the air, when it's allowed to flow, makes the sound come out. Ready? Ah. Right? Pretty cool, huh? Well, next time we're going to do a super cool experiment. If you remember, we did it before, if some of you were there, where we bounced sugar on saran wrap in a bowl. So that's what we're going to do next time. But this time we made a guitar, or it could be a cello, I suppose. And we bent the pencil. Look at that, so cool. You can see it again. And then we bent the water that was running with the balloon so that the electrons could play with each other. The water electrons or ions were playing with the electrons in the balloon, and electrons are negative usually, so they can be considered grumpy if you want to give them a feeling so you can remember it. So negative means one side and positive means the other side. And electrons and ions have both. That's the water that's bouncing around in a cloud. So if you see lightning, it's the same thing. Electrons are bouncing around and moving around, and they move really fast. And then they need somewhere to go. They're bouncing all around. They need somewhere to go. Where should we go, say the electrons? Oh, let's go down to the ground. It's pulling me a little bit, so I'd like to go down there. It looks interesting down there. So the electrons bounce and fall and bounce and fall and bounce and fall and bounce and fall. They come all the way down. They're pulled down by the gravity and the ground. And so they're opposite. So it's pulled down. The negative and the positive pull each other, and they are attracted to each other. They're friends. So that's how lightning falls down. It starts in the clouds, and then it comes down. So the water in our faucet also comes down, and it starts as a circle, and it pulls when it comes down to a shape of a tear, and then it comes back to a circle again. Isn't that cool? Water loves to be shaped like a circle, so it pulls it together. And I'm going to show you a picture of that before we go, and then we'll say goodbye. Ready? Here you go. Do you see? Isn't that cool? It's stretchy, 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 stretchy. That's how rain comes down. Stretchy, stretchy, and then goes back to the circle in the air again. Then it goes stretchy, 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 and then it goes back to the circle. That's why I love circles, because circles are amazing. And so are you. So I hope you guys have a great day. And thank you, parents. And thank you, Wonder School and Wonder Kids. And we will see you next time. Bye-bye from Teacher Chaia. I love you. Bye.